Okay, so hey guys, looks like we have our usual suspects and James McMullen. Welcome, James.
Hello.
James, I'm curious, do you have any specific questions, or are you interested in HDF Cloud or just general HDF?
Definitely interested in the topic that you were discussing today. Just wanted to get more familiarity.
Okay. Which I'm sorry to disappoint you, but I didn't have time really to get that demo ready last night. So I'm going to have to do that in our next session, I'm afraid. But I can maybe answer just general questions you have. So your questions, I mean, you're looking specifically at HDF on Microsoft Azure?
It was really just one of the options I was looking at. And again, just looking for more familiarity. The more I can see it, the more I hope I understand it.
Right, right. So, you know, we started, just some background, we started with HSDS on AWS. And then we had some interest from various people, which led us to, you know, expand it to work on the Azure platform. And it's really, I think there was a blog article I wrote about HSDS on Azure. Laurie, maybe if you can find that, you could post the link to it. But in general, you know, it works pretty much the same as with S3, in that you have the service running as a set of containers and talking to some form of object-based storage. So on AWS, that's S3, and on Azure, it's called Azure Blob Storage. It looks like Laurie has the link posted now. And most different cloud providers who have object-based storage use something that's S3 API compatible. Like recently, we had I had a setup guide for using Tencent, the Chinese-based cloud, and their storage it's their own thing, but it works with the same AWS S3 tools as used on AWS. On the other hand, Microsoft Azure has object-based storage that doesn't use, it isn't S3 compatible. So for HSDS, we had to write a separate driver, if you will, that did the same kind of operation, but using the Azure API, right? So that was the biggest change we did for Azure. And the other thing that we did for Azure, which wasn't really, you actually could use it with HSDS on AWS, for example, is support for Azure Active Directory service, right? So Active Directory is a very popular system that, from one of the things it does, it manages identities and roles. So many organizations use Active Directory to manage their users and what rights these users have and so on. And with HSDS on Azure, it seemed natural to want to support those same identities within the HSDS service. Okay, so you can do that, and the Azure setup guide talks about how to connect with Active Directory. So using that, you don't need to create special accounts in HSDS for each user. You use your Azure credentials, basically. And this is set up in such a way that HSDS doesn't need to know, never sees your credentials. It just gets this token, and it can decode that token to verify that this person who says he's jreadey at hdfgroup.org really is jreadey at hdfgroup.org, and so on. So that's very powerful. And you can actually use Azure Active Directory to create actions based upon groups. So let's say in HSDS, you have a certain file, and you want to have write access, maybe read-write access to one group and read access to everyone else. So your group is engineering, right? So you could give the engineering group read-write access to a particular file, and everyone else have read access, or whatever kind of setup you want. So that's much more useful than having to create a bunch of what we call access control lists for each member of this group to have these civic privileges. There's that. And then, so as I was trying to prepare for today's talk, I was kind of reviewing the latest developments in Azure Kubernetes. So James, I don't know if are you thinking about Kubernetes or more Docker, or?
I was looking at Kubernetes, yeah.
Right. So on Kubernetes, there's kind of like the roll your own Kubernetes, which I wouldn't recommend for Azure or AWS. And there's Kubernetes where you utilize on Azure, it's the Azure Kubernetes Service, or AKS. And on Amazon, it's EKS, Elastic Kubernetes Service, I guess. Anyway, so I was surprised since I last dived into it. There's been a lot of enhancements to AKS. So one of the things I noticed is that when you set up Kubernetes using AKS, it's Microsoft runs the manager aspect of Kubernetes, and you deploy these nodes that will run the pods. And one challenge with Kubernetes, at least before, was that setting up the right number of nodes, right? So if your workload, say, is rather small, but you have a large number of nodes, you're spending more, right? Because you're paying for these VMs. They're not overly utilized. Conversely, if you have, say you launch a bunch of applications in Kubernetes, and now you have more pods than you have resources for, you'd have to manually go in and dial up the number of nodes in your cluster, right? So that's a bit of a hassle. And the nice thing with AKS is that you can set it up so that it will automatically change the number of nodes in your cluster to meet your demand, right? So now you don't have to manually tweak with it and adjust it all the time. It's going to naturally scale to whatever set of pods you have running. So that's good. And you can also have this option. There's like 4 or 5 different options on how you want to utilize these different types of pods. So in Azure, they have these low-cost VMs that you don't have a guarantee that the VM won't be yanked away from you, right? But if your workload is such that all your applications are interruptible, in the sense that if, say, a node in your cluster suddenly went away, it wouldn't hurt anything, then that's a good option, right? So you get these low-cost nodes with a proviso that they may leave anytime, but hopefully you've created this, your application workflow in a robust way, that infrequent event wouldn't be critical, right? And yet there's another thing which I haven't really researched yet, which are these running virtual pods. So you can have pods that don't run on your VM, they're run for you by Azure. And then you kind of get this optimal scaling, right? When you're running pods on your own VM, and then say there's an increase in number of pods in your cluster, but not enough resources, it takes time to spin up additional VMs, support those pods, right? Maybe a couple of minutes. If instead you can have these pods run under the Microsoft system, they supposedly will have enough, kind of excess capacity to soak up those pods, and you'll get quicker response time. So it's a lot to it, and it's pretty complex and a rapidly changing area. So maybe that's helpful. I'll be looking more into the recent changes with Kubernetes, and maybe in our next call doctor session, we can do more of a hands-on walkthrough of that.
Appreciate the overview. One question, I guess,
Sure.
I did have. The HSDS GitHub for Kubernetes deployments, are those up to date to work with the latest way to deploy?
I think not. So it's one thing I want to do and go through and make sure those are synced up with the latest and greatest stuff. So here, let me show what I'm talking about. Do you guys see my desktop?
Not yet.
Not yet.
No. What did I do? Yeah, so another small disaster is I spilled coffee on my MacBook and it died. And so now I'm using a new computer, a Linux notebook, which I'm trying to sort out what's going on. That's strange. I didn't see. Oh, okay. Oh, here. It was hiding behind the other window.
Yep.
Okay. So, so if you go to, let me show you what James was talking about. What is going on? Let me just go and do stuff. It's strange. Is there what? Okay, I don't know what's going on. One second. Hey, sorry about that. Do not look at the super secret code. Anyway, so in the HSDS repo, we have, for example, different setups for this. And this was actually, I was thinking about this. In this session guide, it's not walking through how to use the Azure portal web application. It's having you run the Azure command line tools and then go through all these steps to create the deployment. And in a way, that's good in that you can save this as a set of scripts and such, and then you have a repeatable way to create the deployment. On the other hand, I feel sometimes by using the web console, you might see like different options that you weren't aware of, and you can explore. Whereas this is kind of straightforward. It'll just deploy in a certain way, and that's what you get. But anyway, I'm going to verify that all these things still work as advertised. And then if not, I'll be updating this page. The other thing I want to point out about Kubernetes. So if you go to HSDS admin Kubernetes, you have these different deployment YAMLs. And unlike with the Docker Compose files, these pretty much have to be customized per deployment. So if I look at this Azure YAML, you have things like here, like, one thing you might come up is here, we're not deploying this in a namespace, right? So do you want to use a namespace or not? It kind of depends on your setup and what your needs are. For those who don't know, a namespace is a Kubernetes thing where you basically partition the names of things to separate groups. So you could have like a namespace that's like HSDS, and then all your HSDS artifacts could be in that one namespace, right? So typically, you will have to tweak this a bit for your particular setup and such, right? So for example, under volumes, so volumes are Kubernetes persistent data stores that could be accessed by the pods. So we have a volume called accounts, and that accounts volume is used to create the user password list. On the other hand, if you're using Active Directory, you don't need this, right? So there's kind of like this related things that will require some changes. All right.
While you're right there, I noticed
Sure.
the line 71 and 74. That's kind of broken up differently than was done with AWS. Is that intentional?
Oh, you mean just how the YAMLs?
Yeah, so
Yeah.
I noticed with the AWS deployment, it's just config and has both config and override together. It's a small detail, but it was something that I was coming across having some issues.
Right.
Trying to do this.
Let me
myself.
go to the AWS one.
I know it's kind of in the weeds, but since you were there, I figured I'd ask.
So we have, was it here?
It was under the DN, I think. Maybe. I'm sure you'll come across this when you're
Yeah. Okay.
looking it over. It's just
Mhm.
something that maybe it was a difference that I saw trying to decipher.
Right. And then, there's one thing I've been thinking about is on the subject is I really hate this having to, maintain these different Kubernetes deployments, right? So we have kind of a generic one, we have two AWS ones, we have an Azure one, we have a POSIX one, and then you have these supplemental things like to create the config map, to create secrets, the RBAC rules, the HSDS service. I'm thinking maybe it'd be better to generate these YAMLs on the fly. You imagine you have a YAML generator script, right? And you provide some set of criteria. Say, I want to deploy on AWS, but I want to use Active Directory and so on. And then it would spit out a YAML for those particular set of parameters, right? Because it gets a little hard to manage a bunch of these sample YAMLs that are similar but different because they're for Azure or AWS or whatever. Just an idea. So James, if you don't mind me asking, have you had experience yourself with Kubernetes in other contexts?
I'm fairly new to Kubernetes. As you're saying, the complexity has definitely been hard to get past. But yeah, I mostly started looking at Kubernetes because of HSDS and the use case that I've considered. So.
Okay. If I don't mind, you don't mind me bringing on a spot, could you expand on your use case? And
sure. Yeah, so I mean, the use case that I would like to use it for is related to the other HDF project, Firefly, and how the different services could work together with HSDS to handle data.
Right.
So,
making
use of the progress that you all have made in those areas, and HSDS being a fairly mature platform to start from.
Yeah, that sounds really good. I like this thing of using HSDS with other applications and having everything run within the same Kubernetes cluster, right? So you probably heard about the Kubernetes ingress controllers, right?
Yes.
If you if you have a service, actually, I think of. Let me see if I usually get in trouble when I try to do on-the-fly demos, but let me see if this works. Like this is my notebook, and for playing around with Kubernetes, I've been using something called micro K8s. That's how you pronounce it. It's basically you have Kubernetes running as a single node on your desktop, right?
I've been doing the same thing with K3S, but yeah, there's
it's a similar thing, I guess, right? So if I can do like this, I have one node running for 69 days. And then if I do kubectl get pods-a, you see here I have a bunch of HSDS nodes, and then there's Kubernetes system nodes. I have Minio pod. I said nodes, I meant pods. Minio is a an S3 API compatible thing you can set up under Kubernetes. So with this, I can have my HSDS pods talk to what looks like the AWS S3 API gateway, but really it's just going to Minio on my desktop. Does that make sense? For example, if we do, we exec into one of these. Oh, and I mentioned namespaces before. You see the namespace here, right? So you have Minio devs, a namespace, these various Kubernetes things. I'll talk about Toaster in a second, and I have HSDS dev as its own namespace. So when I do kubectl -n HSDS dev get pods, I see just those pods in that namespace. And then if I exec into one of these pods, let's see. I haven't really mastered my copy and paste yet. So I think it's --sn. Okay. So it's a default. So this each pod has a SN and DN container running on it. So this landed me in the SN container by default. And if I do env grab AWS, oops, I didn't do that. Let's see. Yeah, so here's like this config override we were showing. So the AWS S3 gateway is HTTP minio.minio-dev svc.cluster.local:9000. So Minio is running as a pod. It has a Kubernetes service, and the internal endpoint, internal meaning from another Kubernetes pod running on the same cluster, will be this, right? So when this pod wants to talk to S3, it's going to this URL. And that, meanwhile, will be talking to this Minio that's running on the notebook, and it's actually using the local disk for storage. This may be a little deep in the weeds, but I thought it was interesting for getting to Kubernetes. And another thing I set up is what I call a toaster. So I mentioned that it's easier to talk to HSDS Kubernetes service from inside Kubernetes than from outside. So on my notebook example, I didn't set up the ingress controller to access HSDS from outside Kubernetes. Instead, what I did is I have this toaster pod. So remember when I did actually I have this up here. I had this pod called Toaster, running a toaster namespace. And if I go here, I can SSH into that pod. And from here, I can talk to HSDS. So the server is HSDS on my notebook, microcase, and the endpoint is similar to what we saw with Minio. It's this hsds-dev.svc.cluster.local:5101. So here, this HSDS is that namespace, right? So the HSDS service is running under this HSDS namespace. So it's HSDS service name .hsds dev namespace name .svc.cluster.local to get to the service endpoint. And then you can do things like you do all your typical stuff. So I was trying out these NSEP3 files here. And then, so here, it's a fair size file. So if I do H-V, it's 45 gigabytes. So I use this as kind of like a test data set up for desktop testing and so on. But then, so I can run scripts from this toaster pod that talks to the Kubernetes pods. Talk to the HSDS pods, and those HSDS pods are talking to the Minio pod, which is talking to the disk. So I guess what I'm trying to say is I kind of replicate something that has a lot of the pieces you see in a cloud deployment. But here, if I screw things up, I'm only hurting my own desktop. I'm not causing mayhem in the cloud or running up a big cloud bill. So it's kind of relaxing in that respect.
Yeah, that definitely makes sense. It's a good option.
Right. All right. So I'm afraid maybe that wasn't as helpful as you're hoping. But like I said, next time we will try to get things properly prepared, and we'll do some diving in to the Azure.
Appreciate that.
All right. All right.
All right, sounds good. We will be back here next week. Even though we're starting to get dangerously close to the holidays, I don't think we'll be taking any sessions off. So back here Tuesday, 12:20 Central. And thank you, John.
Thanks, good.
Thank
All
you.
right. See you later, guys.
Bye-bye.
Great. See you. Bye.